So just to substitute f of 0, which is nothing but 0, plus z is here. F dash of 0 is nothing but 1. See, f dash of 0 is nothing but 1. So 1, z multiplied by 1, plus z squared by 2 factorial, f double dash of 0. Okay, f double dash of 0, 0. So that becomes 0 here. What of the other one? F triple dash of 0, which I have not calculated. If you calculate, you will get minus 1. So as I said earlier, minimum 3 terms should exist. Minimum 3 terms. So you have to find out minimum 3 terms. See here, minimum 3 terms. So you have 0. The first one is z. Second one is z cube minus 3 with a minus sign. This becomes 0. So you have z. This becomes the second term, and this becomes third term, z to the power by 5 factorial. So this is for the expansion of sin z at z equal to 0. Is it okay? Simplest one. Now we will go for z equals pi by 2. So z equals pi by 2. The similar process. F of z equals sin z. You have to substitute for z equals pi by 2. So you have f of pi by 2 equals sin pi by 2. Sin 90 is 1. So first term is over. The second one, f of z equals cos z. Okay, so f of pi by 2 equals cos pi by 2. You have differentiated. F dash of z is nothing but you have differentiated. So cos pi by 2. Cos pi by 2 is nothing but 0. And third term, f double dash of z equals minus sin z. Cos z minus sin z. So instead of z pi by 2. Instead of z pi by 2. So sin pi by 2 1. So minus 1. So minus. Similarly, you can go for the third one. F triple dash of z is nothing but minus cos z. So minus cos pi by 2. Answer is 0. Now use, as usual, we have to use Taylor series. So you have f of pi by 2 plus z f dash of pi by 2 plus z squared by 2 factorial, f double dash of pi by 2 plus z cube by 3 factorial, f triple dash of pi by goes on. What is f of pi by 2? The first term, f of pi by 2 equals 1. So 1. What is f double dash? F dash is 0. F double dash is minus 1. So it goes on. So similarly, you can go for 1 minus z squared by 2 factorial, z cube by 3 factorial multiplied by 0. That term will get cancelled. The next term will be z to the power 4 by 4 factorial. So your f of z sin z can be expanded in terms of power series, Taylor series as like this. So we have 3 terms. So minimum 3 terms. Is it okay? The simplest one. So we have expanded f of z, which is equal to sin z, using Taylor series at z equals 0 and z equal to pi by 2. Now we will go for some other problem. F of z equals cos z. We are going to expand in terms of Taylor series at z equal to pi by 4. Simplest. So f of z equal to cos z. F of pi by 4. F of pi by 4, which is equal to cos of pi by 4. Cos pi by 4. Cos pi by 4 is nothing but 1 by root 2. So f of z, you will have to, f dash of z, you will have to differentiate with respect to z. That will give you minus sin z. So you will get minus sin pi by 4, which is nothing but minus 1 by root 2. Then next one will be, you have to differentiate this. So that will, you will get as minus cos z. So minus cos pi by 4, that will be minus 1 by root 2. F triple dash of z equals sin z. So f triple dash of pi by 4, which is equal to sin pi by 4, which is nothing but 1 by root 2. So now again we will have to use Taylor series. F of z equals f of a plus z minus a by 1 factorial, f dash of a goes on. Now we are going to substitute. The first one will be 1 by root 2. Can you remember, this is 1 by root. So we have 1 by root 2. The second term will be z minus a, z minus pi by 4 divided by 1 factorial. Where f dash of a is nothing but 1 by root 2. So similarly you can go for the third term and fourth term goes on. Here there is no 0 here. So you can take 3 terms immediately. So you have, I can pull 1 by root 2 out. 1 by root 2, because 1 by root is here, 1 by root 2 is common, I can take it out. So 1 by root 2, the remaining terms I can write in terms of power series here, Taylor series. Very easier. Any doubt? Now we will go for another problem. E power minus 2x. We are going to have f of z equals e power minus 2x at a equals 0. We are going to expand. E power minus 2z. Okay, this is not x, this is 2z. So f of z equals e power minus 2z. What of z equals at a equal to 0 it is given. So this becomes e power minus 0. Answer is 1. Then f dash of z, e power minus 2z, when you are going to differentiate, that will become minus 2 e power minus 2z. When you are going to just differentiate this, you will get minus 2 e power minus 2z. Now substitute for z equals 0 here, at a equal to 0. You will have e power 0, the answer will be 1. 1 multiplied by minus 2, that will give you minus 2. Is it okay? Then f double dash of z equals 4 e power minus 2z. Now again substitute a is nothing but z is nothing but a here. So we have 0 substitute, that will give you, substitute the 0, that will give you 4. F double dash of z equals minus 8 e power minus 2z. So that will become 1. So minus 8. That goes on. As usual, you will have to use Taylor series. We have used Taylor series and substitute the value for each term. So f of 0, the first one is nothing but 1. Second one is nothing but minus 2 here, minus 2z. See, this z is here. Plus the third term will be 4. So 4z square by 2 factorial. Similarly, you can go for the other terms. Is it okay? Simpler. This is in terms of summation terms. We can write in terms of a short form. Okay, this is in terms of series. This is summation form. Now we will go for f of z equals ln z square plus 1 at z equal to 0 at a equal to 0. Okay. So f of z equals ln z square plus 1. So as usual, ln z square plus 1, as usual we substitute z equal to 0. So that will give you f of 0, which is equal to ln 0 plus 1. So which is nothing but ln 1. Ln 1 is equal to 0. So answer is 0. Is it okay? So we will go for the second one. Now you will have to differentiate. Ln z square plus 1. When you are going to differentiate, we will have to use ln z square plus 1. Correct? So ln z square plus 1 will be 1 by z square plus 1. You should. Then we will have to do this. That is, I repeat, ln z square plus 1, we are going to differentiate. So that will be 1 divided by 1 by 1 plus z square. We will have to differentiate this. So that will be 2z. So 2z by 1 plus z square. Is it okay? I repeat, ln z square plus 1, we are going to differentiate. 1 divided by 1 plus z square. We will differentiate z square. So that will be 2z. So 2z divided by 1 plus z square. Now we will have to again substitute for z equal to 0. Numerator z is there. So answer must be 0. So f of 0 equal to 0. Then third one, 2 minus 2z square divided by z square plus 1 whole square. So this is, you will have to differentiate this. As usual, you will have to differentiate with respect to d of u by v method. Okay, d of u by v method. So b square v du minus u dv, the same method. So v square is nothing but 1 plus z whole square. So this must be whole square. There's a mistake here. 1 plus z square whole square must be there. There's a mistake here. Don't forget. This must be squared because v squared. So you write 1 plus z squared as it is. V du is nothing but, you will differentiate. So this becomes 2 minus 2z. You will have to differentiate the denominator. So 1 plus z squared. This is nothing but 2z. So 2z I have written. Then 1 multiplied by 2, 2 multiplied by z squared minus 4z squared. So 2 plus 2z squared minus 4z squared. So 2 minus 2z squared, 2 minus 2z squared divided by 1 plus z squared. Any doubt? As usual, you will have to substitute z equals 0. So this becomes 0. You have 2 divided by 1. Say answer will be 2. So f double dash of 0 is nothing but 2. Similarly, you can differentiate. You have to differentiate this. So it's very tedious. So what you have to do? Again, same u by v method. So that will become z squared 1 to the power 4. You will get 4. Okay. Then in the numerator, you will have z squared plus 1 whole square will be there. Other term also will have z squared plus 1. You can pull z squared plus 1 common out and strike it out. Z squared plus 1 divided by z squared plus 4 to the power 4. So that will become 3. Okay, simple one. I repeat, in the denominator we have z squared plus 1 to the power 4. In the numerator you will have the same term of z squared plus 1. That can be striked out, numerator and denominator. You will get z squared plus 1, strike it out, that will become 3. And substitute for z equal to 0, you will get 0. Because 4z exists. Immediately you can say when you substitute z equal to 0, you will get 0. No other way. Now we will go for f to the power 4. Similarly, u by v method. F to the power 5. U by v method. You will get the answer exactly like this. Okay. Now, f to the power 5 is given by this. F to the power 6 is given by this. And we have substituted for f. We know f of 0 equal to 0, f dash of 0 equal to 0, f double dash of 0 equals to, f triple dash of 0 equals 0, f to the power 4 of 0 equals minus 12, and this becomes 0, this becomes 240. Okay, now you have to use Taylor series and substitute the suitable terms. So f of 0, first one is 0, second one is again 0, third one is start, so it starts with 2, third one is 2, so it starts with 2, 2 divided by 2 factorial z square plus 0, next term is 0, next term will be minus 12, next term will be 0, the last term will be 240. So you can write the starts with z square term minus z to the power 4 term. Okay, here there is a mistake here. What must be? Is it okay? Minus 12 divided by 4. What is the answer? Minus 3. So you will get minus 3 divided by minus 3 z to the power 4. The last term you will get this. No, I don't think so. You will get minus 12 divided by 4 factorial. So 4 factorial. 4 factorial is nothing but 4 into 3 into 2. So you will get 12, 12 will go off. You have 1 divided by 2. 4, 3, 2. 4 3s are 12. 12 divided by 12 will get cancelled. You have 1 by 2. So this must be 1 by 2. Z to the power 4 is not there. So extra I have written 1 divided by 2 z to the power 4. So there's a mistake here. It is not z to the power, it is 1. It is 1 divided by 2 z to the power 4 with the minus sign. Plus z to the power 6 divided by 3. 6 factorial, you will have to go with 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2. And you will have to divide 240 divided by 640. 6 factorial. So we can write this as summation form like this. Okay. For example, when you substitute n equals 0 here, n equal to 2, we will substitute n equal to 2. n equal to 2, this will become positive sign. Listen to me. For n equals all even number, this will become positive sign. For all odd numbers, this will become negative sign, minus sign. So when n equals 2, this will become a positive number. Fine, first point. Second point, n equals 2, what is the n equals 2, you will get n equals 2, you will get, yes, 6. So z to the power 6 divided by 2 plus 1, simple one. N equals 0, this will become 1, this will become z square 2, this will become z square, see z square divided by 1, the first term. Is it okay? So this is a geometrical series and this is in terms of summation series. You can expand this one with the same answer. So now we will go for different problem. Find the third order Taylor polynomial. So it is asked, purposely it is asked, you have to find out the third order Taylor polynomial. So you have to find out the third term in Taylor series. So this is what the question is. Okay, this is what the question is. So it's given as f of z equals z cube plus 3z square minus z plus 1 at a equals 1. So we'll have to find out third order, up to third order. So it is asked third order polynomial. So third order term we'll have to find out. So f of 1 equals z cube plus 3z square minus z plus 1. You substitute at z equals 1 here. If you substitute z equal to 1, you will get 4. Correct? You have 1 plus 3 minus 1 plus 1. This one will get straight and you will get 3 plus 1, which is nothing but 4. Then you will have to differentiate with respect to z. So that will give you 3z squared, 6z minus 1. This becomes 0. At z equal to 1. So this becomes 3 plus 6 minus 1, which is nothing but 8. Similarly, you can go for the third one. Third one is very important. It is asked only the third order term. So first term, second term and third term. Okay. So f triple dash will be your 6. After that you cannot do it. This will become 0. Very good. This will become 0. You can't do it. F to the power 4. 4 of z we can't do it. Up to only 1, 2, 3, 4. 4 terms only we can. But what is asked? Third order polynomial is asked. So you substitute in Taylor series. Taylor series is given by this. You substitute the first term. So that will become 4. You just substitute the second term. 8 multiplied by z minus a. A is given as 1. So z minus 1. Next term will be z minus 1 whole squared. Next term will be z minus 1 to the power 3. Okay. Now, so f3 of z is nothing but z minus 1, the first term, second term in terms of z squared, and this will be your third term in terms of z. Last term is constant. So this is f3 of z. So third order Taylor polynomial is given by this expression. Any doubt? Now we'll go in a different manner with the same formula, but we are going to write in terms of summation form. So this is your Taylor series. Now we are going to write this Taylor series in terms of summation form. F of z is analytic function which we used already in complex numbers. That's the reason that in the syllabus it has been added subsequently. So first we studied complex numbers. Okay, analytic function and all those things. Cauchy-Riemann equation we started with. Then after that Taylor series, it is followed by complex number. Then after that we are going to apply some problems. Applications of problems are very important in physics. That's the reason that this unit has been divided into 3. First one is complex number, then which is followed by Taylor series, which is followed by some applications. F of z is analytic function at all points inside a circle C with its center at the point A and the radius is given by R. So z0 mod of z0 minus A, which is equal to R. So this is the radius, and this is Taylor series, and Taylor series can be written in terms of summation form exactly like this. So we know this. Now we are going to use this form for solving some problems. Let us see. Now before that, putting a equal to 0 in that equation. In that equation, putting a equal to 0, which becomes exactly like this. Correct? What we call this as Maclaurin series. Taylor, Maclaurin, Lawrence. Taylor from UK. So English scientist, and he lived in the year 16th century, 16th to 17th century. Taylor. Okay. Brooke Taylor, Englishman. So putting a equals 0, so those people, Lawrence, Maclaurin, they lived in the year 16th to 17th centuries. So putting a equal to 0 in equation 1, you will get this. Okay, what we call this as Maclaurin series. So this is what I told you. Maclaurin series is the special class of Taylor series. And another form also is there. Putting z equals a plus h will give you this type of form, this type of series. See here. So f of a, instead of just substitute a plus h minus a plus h minus a whole square. Okay, So this is of kind, another kind. Now expand cos 1 plus z about the point z equal to 1 using Taylor series. Now we are going to use in a compact form. Okay, not in power series. We are going to use summation series. Okay, so f of z equals cos 1 plus z. And while expanding, cos 1 plus z can be written as 1 plus z plus n pi by 2. Very, very important. Okay, cos n pi, sin n pi, they are all in terms of series. N equals 0, n equal to 1, 2, goes on. So f to the power n is given. So that means cos 1 plus z plus n pi by 2, where n equals 0, 1, 2, 3 goes on. For n equal to 0, you will have first term. N equal to 1, you will have second term. N equal to 2, you will have third term. Goes on. So Taylor expansion at z equal to a is given as. So z equal to a, which is equal to 1, is given as in this term. This is summation form, which you are going to write this as a equals 1 here. Z equals a equals 1. So I have written the same form. F of n of 1, which is equal to cos 1 plus 1, which is nothing but 1 plus 1 is nothing but 2 plus n pi by 2. Okay, 2 plus n pi by 2. So you have now substituting equation 2 in equation 1. So this is equation 2. You are going to substitute here. You will get this term multiplied by this term. This is your f of n. F to the power of n. Okay, this is your f to the power of n. You substitute here. You will get this equation f of z is nothing but this multiplied by this term. Okay, now we will go for f of z equals 1 by z about z equal to 1 and z equal to 2. So as usual, you have to go with the formula f to the power of n z equals nothing but minus 1 to the power n factorial divided by z to the power n plus 1. So f dash of z, which is nothing but minus 1 z to the power minus 2, which is equal to minus 1. This can be written as 1 divided by z square, which is equal to minus 1 divided by z square. Similarly, f double dash of z is nothing but differentiate. So that will give you minus 1 multiplied by minus 2 will give you 2. Z to the power minus 2 differentiate, you will get z to the power minus 3. 1 divided by z cube you will get, which is equal to, you just substitute z equal to 1, you will have 2 divided by, so there's a mistake here, 2 divided by z cube. Yeah, it's okay. You will get minus 1 to the power squared, which is nothing but positive value. Minus 1 to the power squared, which is equal to positive value, you will get 2 divided by z cube. Similarly, differentiating this will give you minus 6z to the power minus 4. You will get minus 1 to the power 3. Here you have 3 factorial, z to the power 3 plus 1, that is nothing but 4. You will get minus 1 to the power 3, odd number, minus is there, so minus. 3 factorial is nothing but 3 multiplied by 2, 6. 6 divided by z to the power 4. So now we will go for z equal to 1 here. So we have simplified your f of z, fn of z. Fn of z we have simplified. Okay. So about z equal to 1, your f of z is given by summation of Taylor series, which is nothing but this term multiplied by this term. We have found out this term earlier. See, we have found out this term earlier. So these are all f to the power n of 1. These are all. So this term is there. We have expanded this term. Correct? We have expanded this term. N factorial, this n factorial will get cancelled. Now you substitute the first term, second term, and third term goes on. See, you have to substitute the first term, second term, third term in place of f to the power n of 1. I repeat, this is we have found out. See, we have found out f to the power n, f to the power 1, f to the power 2, f to the power 3 goes on. We have found out. So this is your f to the power n. Okay, this is another term. So now z minus 1 to the power n. This term can be written as the first term plus your second term plus third term. Z minus 1 to the power 0, first term. Second term will be z to the power minus 1 to the power 1. Third term will be z minus 1 to the power 2. This is your f to the power n of first term. This is your second term. This will be your third term. Goes on. So you will get anything to the power 0. Answer is 1. Minus 1 to the power 0. That also 1. So you will have 1. First term. Second term will be minus z. So minus z minus 1. Similarly, you can go for the third term. Okay, now at z equal to 2. So as usual, we will have summation of Taylor series. This term multiplied by f to the power n of 2 this time. Okay, so this can be written in terms of series. N factorial cancel. We have remaining terms. As usual, you will have to substitute for n equals 0, n equals 1, n equal to 2 goes on. Okay, so you will get this becomes 1. So 1 divided by 2. This becomes anything to the power 0 is 1. So 1 divided by 2. Minus 1 to the power odd number. So minus z minus 2 divided by 1 plus 1 is 2. Goes on. So this can be written in terms of again summation of summation form, which we can write exactly like this.